Problem 16. If I had to guess which was the most commonly missed problem on the test, or let's say a test that people got right for the wrong reason, I would guess this one. I could be wrong, but let's go through it. A city is built around a circular lake that has a radius of 1 mile. The population density of the city is F of R people per square mile, where R is the distance from the center of the lake in miles. Which of the following expressions gives the number of people who live within 1 mile of the lake? So a couple comments here. So density, which means exactly what they said here. It means the number of people per square mile. So, okay, and so basically what you have is a variable density. So maybe the closer you live to the lake, the more people, would be there, or maybe the farther away you live from the lake, the more people would live there. So anyways, this is a variable density. You also want to know R is the distance from the center of the lake. And then they want to know which of the following gives the number of people who live within 1 mile of the lake. Okay, so if I was to try to draw a picture of the situation, I would draw this perfectly circular lake. Just gonna guess man-made on that one. Anyway, so here you've got your lake, and then they said that its radius is 1 mile. So, or 1 mile. And so here's the lake, okay? And then they want to know how many people live within 1 mile of the lake. So 0 to 1 would represent the lake, and then 1 to 2 would represent what the area that they're asking about. Okay, so they want to know how many people live in there. Notice that every single integral in the options, they're all dr integrals, and since r represents the distance from the center of the lake, let's think about what happens if r changes even in like an incrementally small piece. So let's say you go from 1 to like just you increase your r value just a little bit from 1. So what would that be, If you have this like super teeny tiny increase in R value, then, you'd end up with this little tiny band essentially. So part of the problem would be figuring out how to represent, that area. And then once you have something like that, then you could make integrals add up infinitely many, infinitely small things. So, and then as R increases a little more, you'd have another, little tiny band. So we're just thinking about what happens when R increases? Like how much more do you get and what does it look like? The other thing that we're gonna have to tie in, so I'm just kind of showing a couple little bands that represent what happens when R increases. Okay, the other thing we're gonna have to think about is if we're wanting to add up the number of people in an area, then let's just kind of like get clear on what everything means. So F of R is density, and it means number of people per square mile. And then we want to add up the number of people in an area. So I claim that that would be found by taking the number of square miles in your area and then multiplying it by the density. I hope that makes sense to everybody. If it doesn't, you could always write these out in words and include units of measure and kind of show how things cancel out with units of measure. So in any one of these given bands, like let's say we focus on the yellow one, how many square miles would be in that? So I claim that if this band is infinitely thin, then we're just looking at a circumference. So what's the formula for circumference? It's 2 pi r. And then, so that means the number of people in the area would be 2 pi r times your density. Just a minute, buddy, I'm almost done. All right, so now let's add up infinitely many, infinitely small little numbers of people, shall we? So, so we'll do the integral, and we want to add up these little bands of people as r goes from 1 to 2. And we're just going to pop the formula that represents the number of people in any one of those bands in there. So we'd have 2 pi r times the density. And then you'll need that little dr to make it so that your bands have an infinitely small little width on there. Anyway, the only difference between this and then the answer, which ended up being d, was that they factored the 2 pi out in front of the integral. All right, I hope that makes sense, everybody. I'm not gonna lie, I had a little bit of a hard time explaining that one, so hopefully that makes sense to anybody but me. Have a great day.